Welcome to Chapter 17, 17.4, Safe Heparin Dosage. Heparin, an anticoagulant, is a high-alert medication. To prevent dosage and administration errors, many hospitals use a heparin protocol. Below is a sample heparin protocol. Please note, though, that this should not be used in clinical practice. The book states, this protocol is just an example for our textbook. So your hospital or place of work that you may be working at, the vet clinic, will probably have a different protocol that you need to check into before you start working, or as you're working there. Alright, so the loading dose, which is the initial bolus dose given to achieve a therapeutic blood level of heparin, is based on the patient's weight. A maximum dose is provided so that the patient will not receive a toxic dose of heparin. You will notice that the infusion rate and all subsequent changes are based on the patient's weight in kilograms. Alright, so this is the table that we'll be using, or you'll be using in this book. Okay. And we'll be using it as we move along. Alright, so weight-based bolus dose calculations. So heparin protocol is started. An initial bolus dose of heparin is usually calculated for each patient based upon the patient's weight, as mentioned before. This dose is typically administered directly into the IV, also known as IV push. Okay, so let's go ahead and look at our first example. So, for example 1, the patient weight 154 pounds. Using the heparin protocol table, calculate the loading dose. Use the proportion method. Alright, so when we look at table 17.1, the loading dose, or initial bolus dose, should be, let's see, what do we look at for the initial loading dose? So the initial bolus dose, is 80 units per kilogram. Maximum 8,000 units. Alright, so that's the starting, 80 units. So first thing we're going to do is go ahead and translate the patient's weight from pounds to kilograms. So we're going to go from pounds to kilograms. Because remember, the table is in terms of kilograms. So as usual, hopefully this one is already seared into your brain memory right now. This little conversion we got here, 1 kilogram is the same as 2.2 pounds. So we'll go ahead and set up that proportion, 154, where X is kilograms, or number of kilograms. Let me back that up. Number of kilograms. Okay, we can go ahead, cross multiplying. Solving for X, we're going to get that X equals 70 kilograms. Alright, so now we know that X is 70 kilograms. So the next step we're going to do is go ahead and calculate the bolus dose. Alright, and doing that, let's go ahead and set up the proportion. We know, according to our chart, that above, which we looked at, was the initial bolus dose. Let me write it up here. Initial bolus dose was 80 units per kilogram. Alright, so this is going to be our conversion factor here. 80 units per 1 kilogram. Set that equal to what we know is we have 70 kilograms. So X units, 70 kilograms. I'm going to go say let X equal number of units. Okay, go ahead and cross multiply. And we'll get X times 1 kilogram equals 80 units times 70 kilograms. Go ahead and canceling the kilogram units. And then we can also multiply the 80 times the 70. So X is going to equal 5,600 units. Alright, so the loading dose is 5,600 units. Period. Okay, let's take a look at example 2. Alright, so example 2. Following the heparin protocol table, calculate the amount to administer in milliliters for a bolus dose of 5,600 units, using a supply dose of 1,000 units per milliliter. We're going to use dimensional analysis. Alright, so the first thing we want to do is see if we need to convert any of our units. Well, the dose that we have the dose we want is 5,600 units. Which we found out earlier is the dose for a person who weighs 70 kilograms. Alright, and then the dose that we have on hand, the units we have on hand, let me do that in a different color. The dose we have on hand is the 1,000 units per milliliter. So that's what's on hand, 1,000 units. Okay, and let's see, the dosage unit that we're using, Q, is 1 milliliter. Alright, so all of these are in the measured units that we need, so there is no conversion factor needed. We're all good here. The next we're going to do is go ahead and calculate. Alright, let me change colors here. Alright, so we know that the unit of measure for the amount to administer is going to be in terms of milliliters. So using dimensional analysis method, we're going to do A milliliters, because that's the amount we're looking to administer. Remember A. We didn't have to convert any of the units, so we're going to go ahead and use the dosage unit, which is 1 milliliter per 1,000 units. Okay, we'll go ahead and multiply that by the other factor we have, which is our 5,000 units. So wrong pen. 5,600 units. And we'll just go ahead and put that over 1 to complete the fraction. Now we can cancel out the unit terms there. The units, actually. That's kind of interesting. All right. Now we can multiply across. So AML is going to equal 5,600 milliliters all over 1,000. Dividing that out, we get A milliliters is going to equal 5.6 milliliters. All right, so there is our answer. Let me write that out. What was the question? Calculate the amount to administer. So the amount to administer is 5.6 milliliters, period. Alright, okay, let's keep going. Determining the hourly dose. Alright, so with heparin and other critical medications that require close monitoring, you may need to determine the hourly dose of medication that a patient receives. So hourly dose. In these cases, you will already know the amount to administer. So use the proportion method or dimensional analysis to determine the desired hourly dose, D. Example 3. What is the hourly dose? Use the proportion method. So what we have ordered is 30,000 units of IV heparin in 50 milliliters of, that should be D5W, to infuse at 25 milliliters per hour. Alright, so the first thing we're going to do is go ahead and find H, D, and Q. Make sure they are in the right units. And if they are not, we're going to have to convert. So what is H? Well, the dose on hand, we have, the dose on hand, $30,000 units It's also the amount, or total amount to administer. And then Q, the units we are working with, is going to be the 500 milliliters. A, the amount that we are administering or infusing at is 25 milliliters per hour. Also the flow rate of infusion. Okay, all of these are in the correct units, so we don't need any, or we don't have to do any conversion, so we can go ahead and calculate. Alright, so we're going to go up and we're using the proportion method. So the proportion is H over Q equals D over A. We can go ahead and fill this out. So H is 30,000 units divided by, and what is D? D is what we're looking for, the dose that we're trying to administer, the hourly dose, because that is what we are trying to find. And then A is 25 milliliters per hour. And finally plugging in Q, 500 milliliters. Alright, so let's see which ones will cancel out. Let's go ahead and cross multiply first, actually. So cross multiplying, we get D times 30,000 units equals, oh, I did that wrong. That is D times 500 milliliters. Sorry, correction. Ooh, changed pen halfway through. Alright, redo. D times 500 milliliters equals 30,000 units times 25 milliliters over 1 hour. And I'll just go ahead and put this over 1. So we can go ahead and cancel out the milliliter units there. We'll be left with 500D equals 30,000 units times 25 all over 1 hour. Dividing both sides by 500, we'll end up with D equals 30,000 times 25 units all over 500 hours. Simplifying this out, we will get 1,500 units per hour. Alright, and that is the hourly dose. $1,500 units per hour, period. Alright, and that is it for section 17.4.